Hello everyone, myself Dr. Feroza Nirajkar. So today we will see a MATLAB program on how to compute the circular convolution and verify its properties. This program verifies three key properties of linear convolution, that is commutative, associative and distributive properties, by using the discrete Fourier transform, that is DFT, via the fast Fourier transform, that is the FFT. It performs the convolution operations in the frequency domain using the FFT and verifies these properties in the time domain by using the inverse FFT, that is the IFFT. The workspace is cleared by using the command, that is the CLC, clear all and the close all. Now the user is prompted to input three sequences, that is X, H1 and H2, and the length of the sequence, that is n. These sequences will be used to demonstrate the properties of the convolution. Fast Fourier transform, it is applied to the input sequences X, H1, H2, converting them from the time domain to the frequency domain. Okay. The parameter n, that is capital N, defines the number of points in the FFT, typically the length of the input sequences. This enables easier convolution operation using element-wise multiplication in the frequency domain. Now, first the FFT is performed on the sequences, that is the sequences which we have taken as input or which we are giving as input are small x, small h1, small h2. Now these we are converting to FFT, that is we are performing FFT on these sequences. So now these sequences will become capital X, capital H1 and capital H2. So capital X is FFT of x comma n, H1 is FFT of small h1 comma n, and H2, capital H2 is small FFT of h2 comma n. Now we will verify the properties. So the first property is the commutative property. So the commutative property, it is stated by X convolution. This is the circular convolution, that is dot and an asterisk mark. This is circular convolution. X circular convolution with H1 should be equal to, it should be H1 convolution, that is circular convolution with X. Now we will first find out the circular convolution of the LHS, that is I will take this as capital Y1. Capital Y1 is circular convolution of X and H1. Now we have to perform the inverse FFT on this. So this capital Y1 we will take as small y1. This is the FFT. Small y1 is the inverse FFT of capital Y1. So y1 is equal to IFFT of y1, that is capital Y1. The inverse FFT, it is used to transform the frequency domain result back into the time domain. Okay. The stem function, it is used here. The stem function, this one, it is used to plot the real parts of the FFT results, that is small y1 and the small y2, for better visualization. And here again we are using the subplot command. Here we have taken 3 rows, 2 columns, and this is plotted in the first quadrant. Then we are taking the grid on command. Okay, after that we'll label the x label as time, y label, that is the y-axis, as magnitude, and the title of this graph will be y1, that is, what is y1? It is circular convolution of x and h1. Okay, this was for your LHS. Now what we will do is we will copy this part of the code and we will paste here. Okay, then we will change some parameters here. This was y1 in this part of the program. Here this is y1. We'll change it to y2 because we want to calculate the RHS now. RHS of this commutative property. So y1 will become y2. Here x circular convolution h1 was there. Now it will become h1 circular convolution with x. and y2 is equal to inverse FFT of capital Y2. Subplot. Here subplot was 3, 2, 1. Now this will be plotted into the second quadrant. Earlier here it was plotted in the first quadrant. That is LHS is plotted in the first quadrant and RHS will be plotted in the second quadrant. And we'll use the same function, that is stem real y1. So we are interested only in the real parts. Grid on x label, y label, title. Title will change. Here it was y1, now it will be small y2. Here it was small y1, it will be small y2. And RHS will be h1 circular convolution x. Now we have to display it. So for displaying we are using disp y1 colon and disp of y1. Okay. Similarly for y2. Now we have to check whether these are equal or no. For that we are using a if else statement, that is if is equal y1 comma y2 display as commutative property is verified, or else display commutative property is not verified, and will end here. Next we'll go for the second property, that is the associative property, which is stated in this way, that is x circular convolution h1. Result of this, it is circular convoluted with H2. This is the LHS. And on RHS we have H1 circular convolution with H2. The result of this, it is convoluted with X. That is X is convoluted with H1 circular convoluted with H2. First we'll verify the LHS. Next we'll verify the, first we'll plot the or we'll calculate the LHS. Then we'll go for RHS. So again you have to copy the same code. Okay, previous code you copy, that part of the program you copy and paste it here. Earlier it was y2, now we'll change it to y3. Wherever y2 was there, we will make it as y3 here. This one here, this is capital Y3. So here also it is inverse FFT of capital Y3. This is the small y3. Wherever small y2 was there, you have to replace it by small y3. Wherever capital Y3 was there, y2 was there, you have to replace it by small y3. Sorry, wherever small y2 was there, you have to replace it by small y3. Wherever capital Y2 was there, you have to replace it by small y3. Now first we'll check for the LH1 LHS. Okay, this is the LHS. So this will be the LHS. Now we have to subplot this. We will take this as 3. Earlier it was 2. We have changed this to 3 because we want to plot this in the third quadrant. Then stem real of y3. Earlier it was y2. Now it is y3. You have to plot the real part. Grid on label, x label, y label, and title. Okay, title is, that is we are checking for the LHS of this. Now next we have to go for the RHS. RHS will be taken as signal y4. So wherever y3 was there, capital Y3 was there, again replace it by capital Y4. And wherever small y3 was there, replace it by small y4. Okay, and make the necessary changes here. That is y4 is now the RHS of the associative property. So next is we will display y3 and we'll display y4. Now we have to check whether y3 and y4 are equal. So if these both are equal, that is if is equal y3 comma y4, display associative property is verified, or else display associative property is not verified. Now we'll go to the distributive property. Distributive property, it is given by this statement, that is h1 plus h2. First we have to calculate that. Then x is circular convolution with h1 plus h2, and here on RHS it is distributed. X is distributed with h1 and x is distributed with h2. That is x circular convolution with h1, plus x circular convolution with h2. Now again copy the same part, previous part of the program, and paste here and make the changes. Wherever y4 was there, you replace it by y5. So capital Y5 will be the LHS of this part. Okay, this equation. So LHS, then y5, small y5 is inverse FFT of this capital Wi-Fi subplot. Now it is the fifth diagram. We are plotting for the fifth diagram. So it will come in the fifth quadrant. Remaining everything remains same, and title will be changed. Title for the graph will be changed. That is LHS of this equation. That one. Now we have to calculate for the RHS of the associative property. So for that again we will copy and paste the previous part of the program. So here wherever Wi-Fi was there, you replace it by Y6, and this capital Y6 will be RHS of the equation, associative equation. Remaining everything remains same. Previously here in the subplot it was 5, now we have changed it to 6. Okay, then title will be changed. You have to write this as that is the RHS part of the associative property. Then we have to display this. Okay, this we have to display Wi-Fi and Y6. Now we have to check whether both are equal or no in order to verify the property. So if is equal Wi-Fi comma Y6, display the distributive property is verified, or else display the distributive property is not verified. Okay, so here this program, it verifies the three fundamental convolution properties, that is the commutative property, then associative property, and the distributive property. And the FFT and the inverse FFT are used to transform the signals between the time and the frequency domains, and the properties are confirmed by comparing the real parts of the output signals. So now we will run the program and see whether we are having any errors. So I'll run it. We'll enter the first sequence. So here the first sequence, I'll take it as 3 space 1 space 2 space 1 and square bracket complete. If you miss the square bracket, it will display as error. Okay, then enter the second sequence. I'll take it as 1 2 2 1. Then third sequence will be 2 4 2 4. Then you have to enter the length. I'll enter the length as 4. I'll minimize this. So we'll see what we have got in the command window. Y1 and Y2, these Y1 and Y2 are for the commutative property. You can see both the values, that is the respective values of Y1 and Y2 are same. So this commutative property is verified. Then associative property. For associative property, we'll check Y3 and Y4. So again the corresponding values are same. Therefore this property is also verified. And for associative property, for distributive property, here Wi-Fi and Y6. So Wi-Fi is 28, 35, 29, 34, and even Y6 is 28, 35, 29, 34. See here we have used display as 2 times, no? So this display, when we are taking in the inverted commas, okay, not inverted commas, when we are taking in the apostrophe s, we are getting it as like this. It will display this only Wi-Fi. Okay, now this Wi-Fi, it will display the values, whereas this one, it will display whatever you have written in these 2 commas. Fine. So now we will see the figure window. So this is the figure window. In the figure window, we have 3 rows, okay, 2 columns. First and second quadrant are for the commutative properties. Then third and fourth columns, rows are for the quadrants. Third and fourth quadrants are for the associative properties. And fifth and sixth quadrants are for the distributive properties. Okay. Hope you all have understood. If you have any doubt, you can comment on the video. Thank you.